So this is 4.7 continued. I like to write that down so you can see it in the video. On to some examples. First two are pretty straightforward, so I didn't write them up. So number 10 and 14, let's go over those. So find the general solution to the given Cauchy-Euler equation. And then they're stating t greater than 0. So this is the form that we have. And essentially all you have to do is read off your A, B, and C. So your A is 1, your B is 2, and your C is -6. And then substitute into your auxiliary equation, which is that. Okay, so substitute in, so you'll just do A, and then you'll do B minus A, and then C into here, and then you solve that just like before. So r squared plus r minus 3, you get -3 and 2. And then you substitute into what your solutions are. So here's your solutions. When they're distinct, it's just t to that power, like that. Pretty straightforward, easy stuff. And then we'll do the particulars later in 16 and 20. All right, so those are your linearly independent solutions written out here. And that's it, just like we've done. That's your general solution. Okay, 14, same thing. Find the general solution to this. So you read off your A, B, and your C. A is 1, -3, 4. Substitute into the auxiliary equation. Right, so you get -3 minus 1 is -4, right? Just add it up. And then C is 4. And this time, this is the two repeated roots, or double root. So your double root is 2. And I should say here, basically, therefore, r equal to 2 is a repeated root. And I want to, so you say r equal to 2 is a repeated root. And so when you have repeated roots, we have our form, which is t squared, and then t squared ln t are the linearly independent solutions. And then you just substitute into your form with C1, C2 for your general solution. Okay, so that's the process. Now let's look at another case. This is going to be the complex case. But we're gonna look at the case where t is less than 0. Okay, so here's 16. So find the general solution for t less than 0. So what you do is you replace the t with -t and then solve it assuming t is positive, just like the previous stuff. That's your substitution. So find a general solution to that. We replace t with -t and solve for t greater than 0. So there's your equation. Okay, so let's go and write this out this time. I like to label your A, B, and C, just like you're back in, solving quadratic formula where you write down your coefficients. Kind of like to do that here. So you write down your A, B, and C. Then we have our Augs equation. is this. So you get did I do that right? Where are we at? Yes. So AR squared, again, where I'm going to write down the equation first. B minus A, R plus C. Now substitute and simplify. So that's A is 1, so it's R squared. -3 minus 1 is -4. Yeah, -4 again. -4R. C is wrong there. I was copying the one above. Okay. R squared minus 4r plus 6. Okay, that makes more sense. Equal to 0. All right, so that has complex roots. So, and has complex roots. There's 2 of them, so it has to be conjugates. So they always will for this stuff. So R is, and so you can solve this using quadratic formula, whatever. 2 plus or minus I root 2. And so your alpha is 2. Your beta is root 2. Once you have that, substitute directly into your formula, y1 of t. I can leave off the t part. So y1 is t squared cosine root 2 ln t. Y2 is t squared sine of root 2 ln t. And so the sum of those two with c's as constants, c1, c2, is your general equation. And then you just replace the variable back. So once you then the general, y is equal to c1 y1 plus c2 y2. So it's c1 and then all of that. I mean, why not? You know, just copy it. Oops, of course I took that with it and messed it up. Now I should have just written it out. Okay, and then plus c2 t squared sine root 2 ln t. All right, so that's true for assuming t is greater than 0, because back here, where was it? Well, you're assuming it's greater than 0 and it's fine. So then all you do now is you say for t less than 0, we replace t with negative t. And we have y equal to c1 t squared, that doesn't matter, cosine of root 2 ln negative t. So you just put in your negative t now. Plus c2 t squared sine of root 2 ln of negative t. And then you just say t, that's for t less than 0. So that's all you really do. It's just a little algebra step to do. Okay. Next, let's do number 20. So this is an initial value problem. So let's solve t squared y double prime plus 7t y prime plus 5y equal to 0. And we're going to say y1 is negative 1. Y prime of 1 will be 13. All right, so let's read off for A, B, and C. So A is 1, B we can see is 7, and C is 5. So then we put that into the auxiliary equation. Ends up being r squared, just work this out, plus 6r plus 5, same as above. equals 0. So we factor that. It's r plus 5, r plus 1. Okay, so distinct roots as same as above, right? So first one we did, but now we're just finding C1 and C2 and all that. All right, so you get r is -5 and -1. So your general solution is C1, and it's not E anymore. I was about to put E there. C1 t to the -1 plus C2 t to the -5. All right, so now solve for C1, C2. So we substitute in and solve, right? I mean, that's what you got to do next. So you say y1 is equal to -1, which is given, which is, once you substitute, it's C1 plus C2. That one's easy. And now you got to take the derivative. So, and now since y prime is -C1 t to the -2 minus 5 C2 t to the -6, we substitute in for y prime of 1, which is 13. So that implies y prime of 1 is 13. Now substitute in, so you get -C1 minus 5C2. And I lined them up real nicely there, so you can kind of see, all you got to do is add these now. You just add those up, that's 0. So I'll just show you this next few steps. Add, you get 12 equal to -4C2, and hopefully you got it from here. C2 is equal to -3. So it's -1 is -1 is -C plus -3. So you're just substituting back to solve. Back substitute, and you get C1 is equal to 2. So therefore, we have our particular solution. Y is 2t to the -1 minus 3t to the -5. So did I say general? I meant particular. Either way. Well, not either way. It's particular solution, given the initial conditions, of course. Okay, so that should wrap up chapter 4. And we will be moving on to the next glorious chapters in that book later.